Welcome, everybody. Welcome back to an episode of LlamaIndex webinar series. This is actually kind of like a special episode. We've never really done this before. We were doing a live workshop with Wey from NebulaGraph on how to build RAG with knowledge graphs. And so we have a collab notebook that we're basically just going to walk through today and both explain some of the high-level concepts of how to do this, as well as like how to do this within LlamaIndex. But we'll also probably like share this notebook, right? And kind of have people follow along if you're interested so that you can run it yourself. And so I think as long as you have like a OpenAI key and maybe some way of like installing Nebula, then we can probably just walk through some of the steps. So this will be a combination of just like high level, what's going on with actually knowledge graphs and how do you actually use it with LLMs. And then two is how to use it with LlamaIndex. And Wey has prepared an awesome set of content. I had a chance to take a look. And yeah, we'll figure out the timing. If it turns out there's more content than an hour will allow, we'll kind of just like send the notebook to everybody and go from there. And then if it ends earlier than an hour, then that's totally fine too. But without further ado, let's wait. Let's take it away.
Yeah, thank you, Jerry. Let me share the screen. Okay. Okay, so we can see it already, right? Actually, yeah, and Jerry will share the URL of this shared collab notebook.
Sounds good. Let me do that right now, actually.
Okay, cool. So basically, this is like a tutorial. As Jerry mentioned, we want to walk you through how we can leverage the power of language module, the LlamaIndex, and the graph. So basically, we will walk through three parts of the different angles of how the language module or RAG working with the knowledge graph or graphs. So the first one is the most straightforward way that we are thinking of how we can leverage the language module to accelerate what we were doing towards the data persisted in the graph storage layer. So it's called Text-to-Cypher or Text-to-Graph query. Given that Danny said he will contribute to the Sparkle integration to LlamaIndex. So we cannot say Text-to-Cypher here. It's better Text-to-Graph query. So it literally means we want to speak in a natural language, and some sort of the the module or function will help us query the underneath knowledge graph for us. And Cypher, speak of Cypher, in case some of us are not familiar with the graph word thing, it's actually just yet another query language that's invented by the Neo4j, which is maybe the very first software who was called a graph database. So as I have a quick introduction in last session, so basically we can the narrow definition of a graph database is a sort of database that persists data in a graph fashion, and that is you are storing the nodes or vertices and the relationship or edges in in a graph way, and you can still query them. So Neo4j contributed this query language called Cypher, and they open sourced the standard named OpenCypher, and that's sort of the factory standard of this domain. So fun fact, there is a ISO standard for the graph database or the property graph module database I mentioned it's a narrow definition of the graph database. They are in a module of property graph. There are another type of graph database. They were doing things in the RDF way. So RDF is more a semantic web, semantic search way of fashion of persisting graph data, and they were speaking another language called Sparkle, which is also very awesome thing. So they have different differences. The RDF is more semantic, and the property graph or cipher is more they want mapping more of the the more generic word. So I will quickly walk you through what is a cipher query looks like. So in cipher we use sort of ask art, my favorite thing to express things. You will know it later. So in cipher we just put this as a node or vertex, and the foo here is just a alias or referral of a variable, and tag A is the type of this vertex. So quite straightforward, and we use this to express one lag or edge or relationship between two nodes. So, and the E here refers to a variable, a pointer to this instance of edge. And here the tab X refers to the type of the relationship. So with that defined, we just introduce another clause named match, so that you can then match towards this pattern, and you give the whole pattern of a graph just one hoop directed edge, and you put whole thing equals to P. So P is a variable pointed to the whole pattern, and you return the whole P here. I will give you more, visualized example to make more sense later. So, and you also put a sample limit clause here. So I think it's quite straightforward. And this is another one, and you can put a where clause here to filter all the components in the whole pattern. And here this is actually a NebulaGraph flavored dialect of cipher. Okay, so this is the cipher query, and so why and what is a text-to-cipher? I think it's quite straightforward, because literally it is quite similar to what we are expecting in text-to-SQL, right? So basically, text-to-cipher, the most naive approach of doing so is to doing with zero-shot prompt engineering, and that is when you are asking something against your your fine created knowledge graph, and we just assemble a long prompt to ask the language module to transform this question against the schema of your graph database, and to finally compose a query that's runnable and that's targeting to answer a question. So this is exactly the same way when we're doing the text-to-SQL. And but to me, this is quite a quite exciting capability brought by language module, because previously, without the capability of language module, reasoning and in-content learning, and you can access with your just a prompt, we have to do things in a more disastered way. So this is the example architecture of a project called Wey. So so Siri is just a toy project that I built to demonstrate how we can create a knowledge graph QA system. So in this system, although it's quite small, a tiny project, still we need to implement a bunch of different layers. For example, when you have a sentence come from the front end, you need to handle it in our backend code, and you need to define the logic either in a if else way, a pattern matching way, or you train some sort of modules, and you do the intent matching. That refers to what type of question you're doing, and you want to do the semantic processing to to know the entities, identified entities per sentence. So for example, you want to check the relationship of two components, two entities. So you after you realize it's a relationship checking intent, and you will need to figure out which is the entity A and which is the entity B, and you put them together to call another code to compose your graph underneath graph query language. And after you call the underneath knowledge graph or graph database, return the result, and you translate, you generate the answer based on the query. So everything here is quite relatively expensive before, without the language model RAG diagram paragram. So with language module, what we can do now is basically, ideally, in the lucky situation, you just drop a long prompt, and everything from here to the end, everything was ready. And but in real world, it's not that lucky, because we can face a bunch of different dirty works, best practices, engineering things. So luckily we can do so with LlamaIndex now. So it's literally you just need 3 lines of code to do so. So but we will review this later in details. We have a slightly deep dived how to do that. So the value here, I just want to emphasize, the value here to to graph world is quite meaningful, because this is really cheap and everyone can do it. And so with this, you can really create your say you already have a knowledge graph, but you cannot fully leverage it, because some of your guys in your team, they are domain experts, but still they don't have the competence to write a proper cipher practically. So they have to ask support from the graph admin or graph experts. And B, ideally, if you have unlimited resources, you can create a bunch of different applications that where the your knowledge graph to some sort of pipeline or decision maker automation toolings to enable some sort of smart ops and smart apps, but they are really expensive doing so. So with a language module, this is no longer that. This is a next level, ROI situation. Yes. So this is a game changer to to the graph world, and there are some references in documentation and some of my blog posts. So this is the first part.
Quickly jumping in with a question. I think Himanshu asked, I assume the application of this is not just knowledge graphs, but any GraphDB that supports CipherQL.
Sorry, I missed.
Oh, sorry. There's a question that says, is the application of this not just like knowledge graphs, but any GraphDB that supports like CipherQL? Like, I guess if you make a distinction between knowledge graphs and other types of graphs, I actually probably more context on this than what I do, but it's just a query interface, right? So you just do Text-to-Cypher for a GraphDB.
Oh yeah, great question. It's not limited to knowledge graph. Normally, the RDF pattern of the graph storage is mainly for knowledge graph, but the property graph pattern match some other cases, and the text-to-Cypher can address all the query scenarios. But there are actually some limitations. It requires your schema design should be self-explained. If your schema are defined in a strange way, so maybe it will hurt the performance of the text-to-Cypher. Yeah, and great question. Thanks for pointing that out. Yeah. Okay, and so I will quickly have an overview on the second topic. So this is the graph RAG. So this is basically a term that the LlamaIndex community, Jerry, and we started to use this term. We are not sure if this is an elegant way to to name it. We just call it so. So in our mind, during our brainstorm, gradually, and we started from some of the work existing months ago, started by two of the contributors in LlamaIndex, and I started to make it more to work interacted with the graph store and make it extend some of its possibilities. So for now, we have an image in our mind that the graph RAG is like you basically are doing three things. You just the first step in a query time. The first step is we analyze your question or task descriptions, and we extracted the main entities or relationships. You mean maybe 3 or 4 of the key entities of this task, and maybe we will expand the similar expressions to help better in next step. We are doing the retrieval thing. So and we combine, we have a list of entities or relationships, and then we will do the retrieval towards the knowledge graph. And here for now we are implementing in the exact matching way. So we just search any entities that's in the list of the ones that we extracted before, and we walk through the graph to, like, by default is 2 hoops. So we will walk all to get all the information along with starting from those key entities and get a whole subgraph thing. So you will have more sense later in the demo later. And afterwards, we will combine the whole subgraph in a knowledge sequence to treat them as a normal retrieved content. And we then generate synthesize the answer based on this retrieval. So I didn't mention what is RAG, but I will have details later in the concept. Later, you will have more ideas on why this is quite natural and interesting, and how we are doing so. And we will have a comparison between the this approach towards other ways, like versus text-to-Cypher, or versus the the traditional vector embedding RAG. So the value here, the iteration here that we want to do something till now is because the the knowledge graph it's a it's a refined and refined form of the information, and when they are making the separation of the information into knowledge, it's more fine-grained. So this is comparing to the way we are doing split and embedding way. So it's a normal RAG approach. So I actually in last time when I was discussing with Jerry in public. So last session we have a more detailed discussion here. So in case you miss it, you can check it from the reference link. So and also knowledge graph comes by nature comes with the interconnected structure. So this by nature can somehow help in the whole RAG in content learning pipeline. So there will be some examples later. Yeah, another line points are we recently realized we didn't share this in last time. So sorry. So one of the thing is if we have a existing knowledge graph that the whole team were maintained for maybe years, and this information there is quite treasure and accurate. So we should somehow leverage this in our QA system or our RAG pipeline, because we are dealing with knowledge, and this is the refined version of knowledge. And another thing is knowledge graph is relatively more stable. So in some use cases, when we are imagine you are creating a small single purpose chatbot that's guiding people to choose which floor they should go for on different health issues. So in that case, the language module is smart, but even in a very small chance it comes with a wrong answer, we cannot afford this wrong answer. So knowledge graph is in this kind of QA system, it has an advantage, even it's a old-fashioned thing, but still very useful. Yeah, and last one is the something that we recently talking close to our customers, and we have a use case, interesting use case, that knowledge graph persist the domain knowledge, and that's something can be easily misunderstood without knowledge graph. I will give you a example later. And about how we want to implement and how we want to leverage, and we have some small experiments comparing the different approaches towards graph RAG. You can refer to reference. Yeah, so this is the second part that we will walk you through later. So, and the last one is the knowledge graph building thing. So this is quite so. And this is by what is a KG building? So basically, when we are doing this job, we just prepare processing our raw data that comes with the as the source of knowledge, just quite similar to today what LlamaIndex is doing. But LlamaIndex is more broad to all kinds of knowledge as the knowledge base. But before that, we just treat knowledge as the the entities, and the entities between the relationship between the entities. So we call it triplets. So before when we create a knowledge graph, we just do some sort of neural language processing towards our raw data. And we extracted the entities, we extracted the relationships. We are doing a lot of different works to ensure the knowledge is accurate and in high quality. So this is a relatively expensive thing, either on the resource or the talent wise. But there's another case that we just create a ETL pipeline to streamline our semi-structured or structured data, like from different CSV data warehouse or databases. So we can map some sort of the column, make some adjustments, and map them to a graph fashion. So this is a more close to the generic graph data rather than the knowledge graph. But sometimes they overlap. So previously we use quite expensive efforts to build a knowledge graph, and this had been changed since we have the language modules. So even in GPT-2, we can do a lot of extraction things, ad hoc extraction things, or lightweight extraction things, much easier than before. And the meaning here is, for now, so everyone can just write a few lines of prompts to extract the triplets, the knowledge graph components from a given article, blog post, and you can render it in a beautiful graph way. It's you can do it ad hocly quite easily. So that means, for example, previously I was advocating in the cloud native community, Kubernetes community, that we can wire all your infrastructure's components to a graph database, and that will enable your next level smart DevOps, dev secure ops. And there are a bunch of different exciting use cases that's extremely useful, but not almost everyone will say this is nice to have, but we don't have the the NLP guys, knowledge graph guys in our team. So so on the ROI perspective, this is not feasible. But so in a lot of cases, we want to leverage what the graph can offer, but it's just too expensive to actually maintain or build a relatively usable knowledge graph, and that's where language module comes in. So so LlamaIndex, long time ago, comes with a workable workflow on doing so before I joined the community, and the whole community, and I'm one of them. We set up a more mature way to wire everything up. So now we can just easily put all different kind of data sources, and just like 2 or 3 lines of code, you can create a relatively usable knowledge graph. Not that perfect, far from perfect, but relatively usable. And recently we introduced another interface that you can not just depending on language modules, you can refer to any function. That means you can where your rebuild the state of art open source relationship extraction modules, you can do that. And in the future, we will implement something in a agent way to put in the middle, so you can define a rule to choose either from the language module, from the rebuild, or other modules, or combine the results. So you remove the the knowledge graph expertise from the whole loop, and that's quite meaningful. And you can refer to we have a lot of documentations around this topic, and we are keeping exploring more capabilities. Yeah, so basically these are the 3 main topics that we want to walk through today, and then we will come to the how part. So before we start doing the KG building, the graph RAG, we want to quickly walk you through the basic concept of how we want to do RAG, the retrieval augmented generation. So LlamaIndex comes with a perfect abstractions on putting things together, help us understanding how this works in a best practice way. So you can refer to when I was preparing for this, I realized how how much the LlamaIndex documentation has evolved. So I recommend you to walk through all the chapters. It won't take you too much time actually. So we start with the basic. Yeah. So we start with the basic concepts. So basically, what is RAG? So RAG refers to approach that we want to leverage your private, your data, and on doing the data retrieval based smart application ways. So basically, we just have we have a we have a knowledge that's our private data. When we are handling your questions in a narrow definition, you just query the related information or related content from your knowledge base, and combine your text description and your contents retrieved, and you put it to smart machine learning module to help you synthesize your questions, or even further define what's next step. So that can be more advanced. But basically, in theory, they are in this is the simplest form of what RAG is doing. So with language module, this is there is no everything can be extremely easy and relatively performant. So this is the how we are doing RAG. So if we look into the whole process, basically we can make the whole system in 2 stages. So this is the abstraction of the LlamaIndex. So one is indexing stage, the other is the querying stage. So indexing refers to we just build such a knowledge base system that you can enable your RAG retrieval when you want to handle different type of tasks. So so how we are doing this? So if we look into the indexing stage, we have the following concepts. They are the data connectors or data loaders. So this is part of the ecosystem of LlamaIndex. So there is there's another website entry point called Llama Hub. So that's that's a hub collecting all the open sourced loaders that you can extract data from different sources. For example, there are some data sources who can load data from your Notion, or you're from Logseq, or from Markdown documents, and process them to serialize them in a common format. So this common format was abstracted as the term of documents, and in the most common RAG approach is called split and embedding ways. So in case it's not familiar to some of us, I will quickly explain it. So in that case, we just we leverage the capabilities of the embedding. So embedding is a term refers you want to map your real world things to a vector. So this vector, in somehow, if you are creating using a proper module doing this mapping, it can reflect the actually underneath meaning of this, this component that you map to it. So this component can be a text sentence or can be an image. So for example, if you're doing the image to image search in Google or Bing, so that underneath that can leverage the the vector ways of working. So you just create your existing you have a bunch of different images and you create the embedding, you create a vector per each images and store them, or maybe in your memory. And when you are looking for similar images on given new image, you just search in your vector space, like who are top 3 close similar images. So because your vector, your module that doing this mapping make the vector the more the similar images are more in a closer distance, so that you can achieve the similarity search in in an easy way if your embedding module works perfectly, works well. So so with this capability and this approach, we can do what? We can do semantic search. So for example, if you want to retrieve the the related contents of your given question, so ideally you can you split your documentations, your data knowledge source into different chunks of small pieces of knowledge, and you create embedding per each chunk of them. So in our query time, you can just leverage the the embedding, the vector space similarity search to find any given question, because you will create a vector in same embedding approach of your question. So you can search things semantically. So this is the the most common way when we're doing the RAG, but it's not limited to that. You can refer to the more guides in LlamaIndex documentation. They have like something called the list index that's targeting for the summary approach. So you can check out that. So basically, we have the documents abstracted to define your data sources. And for example, we are doing the embedding thing. We should cut the documentation in small pieces, so in basically similar sizes. So this small trunk was abstracted as nodes in LlamaIndex. And another thing is index. So index literally means different approaches when you're doing the RAG. So for example, as I mentioned, the vector index is just the approach you want to doing the semantic search based on your vectors that's underneath the created by the embedding, reflecting the semantic meaning of the the documentation nodes.
Wait, this is
and
awesome.
Of course,
I just doing a quick check on time. I think given the content of the notebook, I think this is great content. I maybe just to see if we can go through some of the query engine stuff and walk through some of the basic setup, just to make sure we have some demos before it wraps up around like 10:05 a.m.
Okay, sure. I can
Sweet.
speed up.
No worries. There's like a ton of amazing content. I think it's for whatever reason we time boxed this to an hour, and so I think if we can also follow up offline with the notebook itself to see if people can just follow it at their own pace too.
Yeah, sure. So yeah, so knowledge graph index is it's just an index for creating the knowledge graph from data. You're doing the similar approach when you're creating towards the vector index. So this is about indexing stage, and when then we comes to the query time. So in query time, we have we were underneath leveraging those indexes. So in the most higher level API, you have a bunch of different indexes like vector index. You can just create a query engine or chat engine or agent towards this, the index created. And the query engine is just something you put your questions into, you drop your questions to it, and it will come return the final answer to you. And underneath, they are doing the retrieval, as I mentioned, and they will optionally process the nodes that's retrieved or re-ranking or filter them, and then they will pass all the text information attached in the nodes, and synthesize your final questions. So this is the underneath how a query engine or chat engine is doing. So if you want to do some custom advanced things, you can dive into the into retriever or synthesizer things. But if you just want to leverage something out of box, you just call with the query engine, which is the zero shot, and the chat engine it will handle the history conversation for you, something like that. So when we comes to knowledge graph based approaches, we are dealing with the knowledge graph query engine, which is actually our text to graph query way. So they are not, the name is not self-explainable, and we can also create knowledge graph. Okay, maybe I missed another one. And we can also, I missed here, we can also save a knowledge graph index. So we are indexing it. It means we split the data and create extraction and create it as a knowledge graph. So we can call as a query engine. So we will have a knowledge graph RAG based query engine. So this is another retriever approach that you can do our graph RAG as well. So, but the difference here, this one is not dependent related to the knowledge graph index, and that means you don't have to do the query staging thing with LlamaIndex. You can still do the graph RAG. So they are targeting to different approaches, as I mentioned. Not all of your graph are based on data sources, and also you have some legacy knowledge graphs you want to leverage. So this is the way you want to go with. Okay, so this is the the contents. I'm sorry, I maybe I spent too much time here. So
no way, this is amazing. I think it's a good problem to have way too much amazing content to share. I think it's more. I don't really time the format of this, so it's on me yeah. But please go for it.
Yeah, thanks, Jerry. And okay, so then we finally moved on what we are we are talking about. So I just already mentioned, this is just the three components that related to our the three tasks. I'm not going to dive into them. So because you can access them, you can refer to the documentation. So this is the index. This is the so you can, with the index, you can create a query engine or create as a retriever. So we will know why we want to create a retriever later. And if you come with the existing knowledge graph, you want to do the graph RAG. So you can do with this class, this retriever. So you create a knowledge graph with either with the LlamaIndex or you have an existing one. So you want to Text-to-Cypher, so you go with this query engine. And underneath, they are talking with the knowledge the knowledge graph store, the graph store in LlamaIndex. Okay, and this is the preparation step. So I won't dive into, but basically we just prepare our credentials, our connectivity contents. So later I will put OpenAI equivalent of the Azure one, because I am using Azure more in most cases. So, but they are just
By the way,
equivalent.
for that,
Yeah.
if you're following along the notebook, I shared a short gist above. I mean, it's kind of hacky, but it should work to help you plug in OpenAI. And then we'll actually edit the main notebook in just a bit. But Norris, keep going. Yeah.
Wow, cool. So yeah, and next step, we want to, so this is about, you want to prepare your, the knowledge graph storage layer. So in fact, if you want to quickly play with this whole approach, but you don't want to, deal with the storage layer. So LlamaIndex, just like vector store. In LlamaIndex, the graph store, there is a simple graph store. So everything is just files, and LlamaIndex will handle it in a memory fashion. You can still do that. But in this example, I'm I'm leveraging knowledge graph, NebulaGraph, but you can do, we have a lot of other options. Yeah. So if you are doing with the NebulaGraph, you can, use something called NebulaUp. So this is a project I maintained. You can do this in one-liner. So afterwards, you will have a up and running NebulaGraph. So you can access them like this. So this is the lines that you want to connect with your Jupyter to NebulaGraph. And so next thing, we just create a graph space. So think of create a database in MySQL. So this is show databases. So in NebulaGraph is show spaces. So they are different, isolated spaces. And then I just use enter the space and create a schema. I define the types of the vertices and the types of the edges, and I create an index. So basically, this is everything we need to set up a graph database. And after that, you just create storage content. So the content thing in LlamaIndex is just they have service content and storage content. Service content is related to like your language modules, your embedding modules, and your prompt, your configuration or policy of how you want to handle the prompts, the prompt helper, etc. And storage contents, they can be mapped to like your circle database, your vector database, and your knowledge graph database. So I just map the the things to the graph store in the storage contents. Then the first demo here is about how we want to build our knowledge graph with LlamaIndex. So basically here, think of the indexing stage. First, I'm leveraging the data loader. So it's one of the data loader in the LlamaIndex. So this is called a Wikipedia reader. So we can, with that, just couple of lines, you can extract data from any existing Wikipedia pages. So this is my favorite movie in the last year, and we create documents. Remember, from this data sources, and we just pass this documents here in a knowledge graph index. And this is a long run query execution code, because underneath the LlamaIndex will help you split your data into chunks or into nodes, and then call your service context to call your language module to leverage your default prompts to extract your data from each chunks of documentation, and persist them in the graph store defined in your storage content. So here is NebulaGraph. So you can use the simple graph store. So it will just read to your JSON files. And after this one finished, we can, of course, you can persist. There, even you are leveraging the the external storage content, still you have some sort of content in the LlamaIndex memory. You can just persist them in a file, so later you can resume them, and that's how you split your indexing stage between your production query stage. So ideally they are not running in same machines or pipelines, but you can pass the contents in this way, and you can then restore from them. So in next time you don't have to doing again, so exhausting your your tokens. Yep. So this is the the basic approach, the ways that we want doing the KG building. So it's quite easy, right? And I in the reference links, there is another way that you want to call your external extraction functional modules that Logan contributed, and you can find that in the LlamaIndex documentation as well. So okay, this is the KG building part. So then we come to Text-to-Cypher. So Text-to-Cypher is basically just a query engine called a NebulaGraph query engine. Sorry, a knowledge graph query engine, and you just create your where your knowledge graph storage layer, define it to a storage content, which I had just done in last phases, so I don't have to do it again. So if you start from here, so you will do the storage content definition. So it will refer to your knowledge store. So maybe it's Neo4j, Kuzu, or something else like NebulaGraph. And then you just call a few of lines. You will have a text to knowledge graph query engine. Then you just use it. It's quite straightforward. And for example, so this is the line I create a query called "Tell me about a rocket," and you query it, and then I I render how it's doing the query. So basically, if you look into display the response here, you will know it since your answers on who is rocket in this movie, and the underneath is based on the query that composed with the Text-to-Cypher query engine, the knowledge graph query engine in LlamaIndex. So this is the cipher. So basically, we just match this pattern with one entity related to another entity, and we define the starting entity as named as rocket. So we return the the target entity, but the Text-to-Cypher doesn't always fitting all the cases. You will see the shortcome of this approach. One thing is if you're in your knowledge graph, you're not persisting rocket in this way, maybe a small r, or only in other names, not in rocket, then you will have a false retrieval. So so I will compare them later. There is a comparison demo later. So this is another question, how like more complex queries. So what challenges do Rocket and Lila face? So in this case, the result isn't good. So one of the reason is our existing Text-to-Cypher implementation is a zero shot. And another thing is maybe our prompt doesn't handle this query in in a smart enough way. So maybe either we can create a fine tune a better module to have a better performance in zero shot, or we create another approaches like MapReduce or chain of thoughts way to enhance this. But actually, this is not easy. And okay, so we are back in the second part. So let's resume the session from the graph rack. So I think this is the main topic that we want to share with you. Okay. So as I mentioned, in LlamaIndex, there are two approaches that we can actually implement graph rag. So one of them is have the assumption that we build, we index the whole knowledge graph with the LlamaIndex, and that's that's a very good situation that you just want to in a cheap approach to create a KG, but that's not all the reasons. The other reasons to build a knowledge graph with LlamaIndex from scratch will bring the possibilities to link your the entities towards your data, your metadata, and that brings actual capabilities. So we didn't explore enough on this domain, but there are potentials here, and we will for sure introduce more experiments around this thing, because we actually had a brainstorm with Jerry that we believe that this is for sure helpful. So in that case, after we build a knowledge graph with LlamaIndex, we will have an instance of the knowledge graph index, and with that, so this is the basic concept of all the indexes in LlamaIndex. With that, you can directly do this as query engine to directly have the highest API in LlamaIndex, where you just feed your question or task descriptions, and you will get your final answer directly. So it's quite straightforward. So this is code. You just call as query engine, and you have the this query engine, and then you can just call any questions like what challenges do Rocky and Lila face, and as I mentioned, it will extract the key entities, and ideally all the possible expressions, and then do the subgraph query. So this is the subgraph that's related to the main entities, and they serialize them into one dimension sequence that a standard serialization the RAG pipe can understand, and then it will synthesize the final answers based on the whole contents. Okay, so this is the way that we were doing as a query engine. So another way is as I introduced in other cases, one is you have some existing knowledge graphs. Another thing is the source of your graph, not necessarily to be a knowledge graph, maybe a general form of graph, are actually linked with some streaming data from different sources, but they are not extraction, just a form of a data transform. So either of the use cases, we need some sort of interface with the LlamaIndex to enable the graph rag on those standalone external knowledge graph or graph. So in this way, in this case, to LlamaIndex, this is actually only a retriever, because you actually just fetch the information based on your query, and have this knowledge sequence as a node. So this is all we need. So in this case, the interface to implement that is actually something a knowledge graph rag retriever. And with a retriever, you can combine. You can create your own different pipelines, like combine different retrievers, etc. But the most straightforward way is directly leverage the retriever query engine. So this is a query engine. You just give it any retriever, So it will make you into a high-level interface, the query engine. So where you don't have to, do the rest things after retriever on your own. So you can use everything from defaults. So then we can create a query engine that underneath, not from the knowledge graph index, but from the graph rag retriever in this line. So afterwards, everything is similar. They are slightly differently implemented, but in theory, most of things are similar for now. There are some differences that they are mostly related to the metadata, the raw data, documentation that you can refer. So you have those information that can somehow help your retrieval performance, or help your how you want to evaluate on how you want to explain your your whole QA process. So but we will explore more on that. We believe there are potentials in the KG index itself. So these are the more all the things we can do, we can leverage to actually do the graph rag. And afterwards, I want to give some other small examples that maybe you are interested in. So we were talking about the query engine API. So actually, for all the indexes, we can also save it as another thing called a chat engine, as I mentioned in last session. Where comparing to the query engine is like a stateless approach, where you just do a bunch of different zero-shot ping pong queries, and there is no conversation states persistent in a session. But on the other hand, when we are doing the ads query engine, LlamaIndex will help you handle the history of your conversation automatically, and there is a mode here. So I think there are like 3 or 4 modes, so you can look into the documentation of LlamaIndex. But the context one is I believe this is the most simplest implementation, where you just where underneath the memory, LlamaIndex memory will help you arrange your histories and send them together to the Llama language the language module to be aware of your past questions, like when you are asking something related to your last question. So this query engine will be aware of that. But there is the content one is quite simple, because it will directly call your retriever underneath retriever without any judgment. I will compare another mode, you will know it. So for example, we ask who is Rocket and Lila and Groot, and afterwards we can ask do they all know each other. So you can see for the first 3 questions, they just ask do the graph log accordingly, and for the final question, I mentioned the they here, but still this agent just is doing extract no and each other here, and so this retrieval is somehow a failure, we can call it. But as we already have the historical conversation persist in this session, so the answer is relatively acceptable. But it's not it's not perfect in this kind of question that you are referring some entities you talked about before. in theory, they should understand that if they're really with some capability of intelligence, but they are not. They just blindly transform your task into the rock, and just with your states as the conversation. So that's where we can oh yeah. So in this case, they actually not answered this perfectly, because in the answer there is only Rocket and Groot, but Lila was not mentioned. So I have to follow up a question, and then they can successfully answer my question overall. And actually, there are another way of another mode called React. So underneath, they are leveraging the very interesting and strong, powerful capabilities of LlamaIndex React agent. So in this case, we ask the similar questions, but when we are referring to the past questions, there will be an agent out there to observe what you are asking, and here, and they decided to make it into a proper RAG, because here in this graph RAG, they actually query all the previously mentioned entities. So in this RAG, so and in one go, it gave us the questions. So quite interesting. So another thing we can do is if we are using the contents chat mode, so we can easily define a system prompt background, so that the whole chat can be styled in some way. So you can actually refer to the documentation. But in this example, I just compose a wrapper. I'm requesting this chatbot to act as a professional freestyle rapper, and all the questions afterwards will be you can actually if you have a beat, you can actually rap about it. Yeah, so very interesting. Yeah, and finally, so I actually, because I failed to give the whole session yesterday, so I have a time to look into the newest released blog from the Streamlit. So they were working with with the team of LlamaIndex to give a great example. It's a joint work, so we can implement a proper elegant chatbot in Streamlit, like in a couple of 40 lines of code. And I put this is the raw blog, recommend to read, and I implement a similar one here, and you can refer to the code. And this is the demo from the official Streamlit blog. So you can see we implement something similar as I showed before, and we are asking who is Rocket, and we asked follow-up questions. Yep, that worked perfect. And the other thing that I added to this demo was I also showed how the things actually worked underneath. So if you put your questions and click inspect here, you will see lively underneath. And during the retriever phase, they are composing a query, cipher query, to help you generate the the subgraph in two hoop of the graph traversal, and return everything as the retrieved content, and then synthesize the answer based on that. So as we demoed before. So if you are interested, highly recommend to read it, so you can really play with it really in a 40 lines of code. Quite interesting. Okay, the next one is actually in real world we actually don't there is no silver bullet. So in real world problem, you want to push your QA system to a level that user are satisfied with. You normally don't just like our toy project to do one one retriever for all. So there is another level of abstraction in LlamaIndex. It's called the query engine tools. So that is a abstraction that you want to put it. That's how the React agent underneath works. And in that case, you want to define different racks or different query engines. Put them like you have 5 of them, and you just use your language to describe which when you want the agent to judge which kind of question, or they failed to retrieve something, they want to select another query source. So you can just define them accordingly. Actually, I put some of the code in this example code, but I comment out of them. And also you can look into the query engine tools in the documentation. That's you want to look into for the advanced implementation. So with that, mindset, in many times, as Jerry also shared in Twitter, sometimes you just want all of them. If you have like 3 relatively similar approaches of RAG, and sometimes you want all the retrieved contents to finally contribute to your final synthesis of the final questions. That's a common idea when we were improving iterate our RAG system pipeline. So this is another example. So as I mentioned, Text-to-Cypher can be helpful. Like you want to find the possible connections between 2 entities to certain entity, and maybe that's an ideal case. You want to do Text-to-Cypher, because Text-to-Cypher can ideally find all the passes between the 2 nodes in the whole graph. But in many other cases, if your graph RAG is 1 0 shot, it's not that easy to actually maybe even with the fine-tuned language module to help you compose a query, it's not that easy to actually return your required content in one go of Text-to-Cypher. And on the other hand, the graph RAG that you want to just blindly extract the entities and compose your subgraph as the contents, but it won't work perfectly in all use cases. So sometimes you may need to do the both and combine them. So this is already supported out of box in the knowledge graph RAG retriever. So you just put an option called with NL to graph query. So you just put the flag as true. So underneath it will do the both. So this is a new query engine that we want to ask. Tell me about Rocket. And so first it will do the Text-to-Cypher, and then it will do the graph ROC, and finally it will combine the 2 of the node to be the source of the synthesization. Okay. And with this idea, we can also combine the graph RAG and the vector index. So I'm not to implement in this notebook because this is a very earlier experiment that we had done in LlamaIndex community. So it's actually part of our documentations, and you can just refer there. So I'm not to dive into it, but I want to share the interesting results. So basically, this is the workflow when we are doing graph plus vector embedding based RAG in one go. So in the in the indexing phase, we split your documentations and persist them in your vector store with LlamaIndex, or you can also index your knowledge graph, or where it to your existing ones is similar. And when in the query time, you just do the both, just like what we have done in Text-to-Cypher plus GraphRag. So first, you ask the retriever will do the semantic search against the vector space. So find the type 3 similar nodes or the trunk of documentation, and we treat them as a node, as a contact to to do the in-content learning, the RAG thing. And also you in the parallel time we do the graph RAG, and we have another sequence, long sequence, come from the knowledge graph. And after we combine them, the result looks sweet. Okay, let me see. Oh, this is the line that you want to create a vector store, vector index with the vector store in LlamaIndex. So this is the result, the final result. We can see so in the content is we create a RAG towards a page from the NASA from the science events in 2023, and we asked all the science stories or events about NASA, and the vector vector approach have a proper result, and the knowledge graph have a quite short result, because the information by nature were filtered or extracted, so a bunch of details were lost during the KG extraction. But the nature of the KG are they are spread information. So in this certain case, so frankly, this is also cherry picked, but it reflects some level of the facts that it can help in certain cases. You can see two pieces of knowledge were uniquely existed in knowledge graph approach. So after we combine them, we have the best quality in the whole RAG thing. So this is an interesting thing. And to implement that, we just leverage we just manually from scratch create a retriever that consumes both approaches, and we add our own it's just a simple union approach, but actually you can do more advanced things either from the custom retriever itself, or you can add some other advanced things in the node post-processor thing, as I mentioned in the concept part. So this is just a simple union thing, but in the real world maybe you can explore more advanced approaches, but I think I can say that it's quite interesting. So this is the first example that we cherry pick to demonstrate that KG can in certain cases helps, but we can see that vector DB is we don't want to replace the approach that we're doing with the vector store. So we recommend you to indexing for both in a vector way and in a knowledge graph way. So it can help in certain cases with a relatively not that expensive cost. Yeah. So another example here is a quite interesting one. So the trigger of this example was when we were talking with one of our users in the community that they are a vendor they are a SaaS startup to provide a CRM system on certain domain, and their customer will do the QA thing regarding how they want to sell different things, and they found a certain case that with the plain vector RAG approach, there will be some negative results retrieved and finally exist in the question. So this example is they want to ask something about insulated cup, but in the answer they retrieve something regarding the insulated greenhouse. So this is because in some common sense or literary sense, they are indeed connected, given that the information dense isn't perfect against your task. So they are the only things that related. So they were retrieved. But this is, from my understanding, this is because the vector approach, the vector embedding approach, they are considering the common sense, but sometimes there are some domain knowledge that only can be reasoned, can be referred in knowledge graph, because that's mostly what knowledge graph was good at. So in order to demo you the similar question, I create a creepy question that GPT-4 helped me to create. So this is a long question that looks maybe related to some of the storylines in the movie that we're talking, the Guardian of the Galaxy Volume 3, but actually they don't exist. So if we are asking this question, we know that normal people won't do so, but we just want to give a cherry pick example. So the vector approach was food, and they actually gave an answer that's probably most of the contexts are from your fake question, but maybe something is related from the content. So this is the result. But when we are doing so against the knowledge graph, so we can get the knowledge graph will say it's not related. So maybe this is not a proper example, but I want to make sense. You may be looking into this, this example. This is a real world example. Yes, and I think that's all of the content we want to share with you for now.
Cool. So one of the advantages of using vector DBs in RAG is the fast retrieval of similar content using semantic similarity measures on embeddings. For KG approaches, for these knowledge graph approaches, do you get the advantage of like fast semantic similarity for RAG for retrieval?
Yes, I mentioned a little bit about this, but we consider this is something we cannot avoid, and this is somehow the automated approach. We need to leverage the those embedding based similar search, because the hard part for now is actually to find the equivalent the actual related relationship or entities. But for now, we just we just do a cheat to ask language module to expand the similar expressions, but it's not perfect because you cannot exhaust it all the tricky way of express one thing in different ways in when you persist them in knowledge graph. So one good thing is we noticed just a couple of days before, Neo4j actually implement that. They leverage Lucens, they connect Lucens and add a interface from the Neo4j query, so they can do relatively semantic search. And in our team, NebulaGraph, I am one of the guys working on implement it in NebulaGraph as well, and we will we believe this will make push the whole graph rack further. And in the parallel, a young researcher called Diego San Martin in Spain. I'm working with him to trying to combine the embedding-based approaches deeply tied with the graph approach in RAG. And we already have some, promising results for now. And we would like to have a publication like in 1 or 2 months as well. Yeah.
Sweet. One question another user has is they're trying to create a graph database that is more complex in terms of attributes. So for instance, if the sentence is very simple, like Barack Obama was the president, then you can get like Obama as an entity, the relation is occupation, and then president. But if you need like a lot more entity relationship attributes from raw text, are LLMs still good enough to do all that? Or are there challenges here?
Yes, this is actually when we are dealing with the real world problem. This is, really hard. So for now, for what we have explored, there are certain things that we can do. So one thing is, as I mentioned, we definitely worth to give some effort on fine tune a much more single purposed modules that are doing so. Just one thing, but mostly this is for zero shot. And another thing is we need to, when possible, because most of our use cases are not, not for the general case. We are not building the BARD or new being for every team. So we have some, contents that the builders know. So we should in somehow reflect it, either put the information in the schema. So to me, the homogeneous way of the graph that you have every entities in one type and all the relationship in another type, that won't perform ideally in the real world problem. So we need to give some restriction on how which type of the entities and the relationship you want to define when you're doing the extraction. So this information can be also provided as the side contents during in your prompt during the query time. So this will for sure be helpful. And some of our users from our LlamaIndex community are also reached out to me offline. So we discussed about their use cases, and I gave similar recommendations, suggestions. So I think maybe in upcoming months, we will have more real world users, sharing ideas in LlamaIndex community. So stay tuned. Yeah.
Sweet. And then the last question is, so if you already have triplets from our pre-constructed knowledge graph, right now, are you able to build embeddings on top of these triplets and then still use the graph RAG method? Or does this kind of depend on us kind of owning the entire process end to end so far? I could probably take a stab at this, but I know Wey, you've also worked a lot closer with the knowledge graphs. My understanding is that if you right now, to actually generate the embeddings for the knowledge graph for the knowledge graphs, like you do need to construct the knowledge graphs using R constructs, so the knowledge graph index. So if you have a pre-constructed knowledge graph, I don't think we have out of the box ways to just like build embeddings for these right now, unless I'm mistaken. So I think like maybe that's something that we can work on in terms of future work.
Yeah, actually, the embedding approach, existed before I started to contribute to LlamaIndex. There is a, if you remember, there is one knowledge graph abstraction there, and when we were doing indexing phase, there is a process to create embeddings of one hoop triplets and attach to them. I think that's a good start point, and I also see someone is define their own patterns to to pass the message from your key entities align with your graph patterns to combine all the information to pass to the central nodes and put the whole subgraph embedding into this key entities. So this is another approach. So when you are doing search, you are searching the pre-processed graph handling, embedding, semantic search. I think that's an approach. So if your data was not updated dynamically, it will for sure help your performance, I believe. And another sense is as we discussed offline, we can leverage some sort of graph-wise embedding. So that can be somewhat meaningful, but graph embedding is relatively expensive because in most algorithms you have to have the whole picture of the whole graph. So when you're adding something, things are changing. So, but there are still something that's mitigate this limitation. So we will be open to this, and maybe there are some papers already out there I'm not aware of, but they are quite straightforward and promising ideas as well. So, but eventually we will in some level to leverage the embedding, because embedding is really good. I really like embeddings. Yeah.
Great. Well, thanks, Wey, so much for your time. This is part 2 of this series where we basically wrapped up the entire knowledge graph tutorial session. And we'll have, I think the notebook is linked down in the description and comments as well. And so if you have a chance, please check it out, and please let us know any questions, feedback, or future content that you want to see. So thanks, Wey, and see you guys soon.
See you.